Hello, ladies and gentlemen. Welcome back. We are on chapter 5.2, where we're going to evaluate and graph polynomial functions. In a polynomial function, the exponents have to be whole numbers, everybody. Okay, those exponents need to be whole numbers. And the coefficients are all real numbers. All right, now remember, the coefficients are the numbers that are in front of the variable. Now, we're going to be talking and looking at different types of equations with different degrees. All right, so if we've got a degree of 0, that means the exponent is 0, folks. That is just a constant. If we have a degree of 1, then that's a linear equation. Degree of 2, that's a quadratic. Degree of 3 is cubic, and a degree of 4 is quartic. Now, this little chart that I have here, you can also find it in the book with a little bit more detail. So let me pull in the Schoology. And remember, when you go to the section, the folder, 5.2, you've got your book there. If you open that up, and let's take a look at it. Okay, I'm going to make this a little bit bigger so we can see it. So right away at the beginning, you will see, whoa, I went a little too far there, folks. Okay, right there, that's the exact table I have on the screen, but this one has a few more details to it. So you have an example over here on the right. So you can see degree of 0 is just a constant, and that's just an example. Linear, well, 5x minus 7, that's linear. 2x squared, it's got a degree of 2, so that's quadratic. Cubic, it's got an exponent of 3, that's an example of a cubic. If the highest degree is 3, it's cubic. And then if it has the highest degree of 4, it's a quartic, and so on. Now remember, your book has a lot of good examples and things to look at, okay? So what we're going to do next is we're going to identify polynomial functions, okay? But I'm going to go ahead and do it on here. All right, on Active Inspire. So let's take a look. So the first thing, decide whether the function is a polynomial function. If it is, write it in standard form, state its degree and type. All right, well, if we go back and look at what I said at the beginning, to be a polynomial function, the exponents are all whole numbers and the coefficients are real numbers. All right, so if we look at this very first one, 6x to the half power minus 5x, well, we're going to have to say that this is not a polynomial. And I'm just going to use poly for the abbreviation, folks. So this is not a polynomial. Okay, why is it not a polynomial? The exponent is not a whole number. Okay, that 1/2 is not a whole number. Remember what whole numbers are. Okay, 1, 2, 3, 4, 5, 6, 7, 8, and so on. Okay, and they can't be negatives either. They're whole numbers. All right, the next one. Is that a polynomial? Well, first, if I look at the exponents, 4, 2, 3. Those are okay. Those are whole numbers. And the numbers, the coefficients in front, we got -8, -4. We've got the 10, and then there's a 1 in front of the x cubed. Well, those are all real numbers. Okay, so yes, this is a polynomial. Then it says make sure to put it in standard form. Well, standard form means highest exponent to lowest exponent. So that means we need to go write g of x equals. We've got highest exponent to lowest, so -8x to the 4th. Then we need to put the plus x cubed. then minus 4x squared, and then plus 10. All right. Now, state its degree and type. Well, degree 4, which is quartic. Okay, and that's quartic. All right, let's look at the next one. So I look at the exponents, 2 and 3. Yep, that's fine. Those are whole numbers. Okay, now I look at the coefficients. Well, we've got a 1 in front of the x cubed, and we have a negative 4/5 in front of the x squared. Yep, those are real numbers, so all good. So this is a polynomial. Okay, now I'm going to put it in standard form. So this time I'm going to go f of x equals, again, highest degree to lowest degree. So x cubed minus 4/5 x squared minus 1, or you could put plus -1 there. Okay, well, this is degree 3, and that is cubic. All right, one more. So let's take a look. So let's start with the exponents. Uh-oh, I noticed, folks, there's a -2 there. Nope, can't have a negative exponent. So this is not a polynomial. And the reason is, okay, the exponent, -2, is not a whole number. It's an integer, but it's not a whole number. All right, let's move on, ladies and gentlemen. The next thing is, okay, we're going to just do one example of this just to show you. Evaluate by direct substitution. Okay, evaluate by direct substitution. If I pull in again, if I look at the book, ladies and gentlemen, oh, look, there's an example right there. All right. So let's go ahead and look at the problem I have on the screen. Here's our problem, ladies and gentlemen. So direct substitution. So we're going to just go ahead and put this 2 and substitute it directly into x. So we would say f of 2 equals -3 times 2 cubed plus 2 squared minus 12 times 2 minus 5. Now you can go ahead and do each part using order of operations if you want to, but you all have access to your graphing calculator on your Chromebook. So let's go ahead and type this in. So I'm going to go ahead and go -3. Notice I'm using parentheses for all of my substitutions. I highly recommend that you do that. Okay, now I'm going to go ahead and put in the third power. Now I got to use my right arrow key to drop back down. Plus, let's see, then we've got 2 squared. I probably don't need parentheses on that one, but I'm going to put them there anyway. Minus 12 times 2 minus 5. Hopefully I didn't make any mistakes. So what do I get? I get -49. Good, I don't believe I made any mistakes. So I find out that when I use direct substitution and I plug 2 into that, I get -49. Now, there's another way that we're going to be doing this. And yes, you have to be able to do it this other way. You're going to have a mastery quiz on it, and it's going to be on your test. All right, so it's called evaluate by synthetic substitution. Now, see page 338 in your book if you want the actual visual of the steps. Let me pull the book back in. All right, so if I go right here to example 3, let me shrink this down a little bit. There we go. So you can see in example 3 in the textbook, it tells you in words what each step is doing. Okay, so if you need that visual and you need to read it, look at it. I'm just going to say it as I do this problem. All right, so here we go. So first thing I'm going to do, ladies and gentlemen, is I'm going to draw, it's like an upside down division box. Remember, you divide. Okay, so what we're going to do here is we're going to put the x value 2 in the front, or on the side, left side. Then I'm only going to write the coefficients, okay, that are in front of each variable and then the constant, okay? So I've got a -3 on the x cubed. In front of the x squared is a 1, so I put a 1. Then I'm going to put -12. Then I'm going to put the -5. Okay? Now, we're going to bring down that first number, -3. Now we're going to take the 2 and multiply it to the -3. Okay, 2 times -3, we're going to put -6 right there. Now we're going to add 1 and the -6, or we're going to go 1 minus 6. Okay, that's -5. That's going to go underneath. Then I'm going to multiply the 2 and the -5. 2 times -5 is -10. I'm going to write that product underneath the -12. Now I'm going to combine those two. At any time you don't get the rewind and watch me do it again, look in your book also with that example I showed you. So now this is -22. 2 times -22, ladies and gentlemen, is -44. And then I'm going to put those together. And look, oh my gosh, look at what we got. I find out that f of 2 equals -49. Isn't that cool? That is just so cool. That is so cool. Look, I know some of you are like, hey, I like direct substitution. Yeah, that's nice, but you are going to need to know this. See, we got -49 with direct substitution. Here, we got -49 with synthetic substitution. Isn't that cool? All right, let's do another one. Okay, now this one, there's something you need to look out for. Here we go. So I'm going to go ahead and I'm going to make my upside down like divide box. The -1 is going to go in front. Now the coefficients are going to go inside. So the first coefficient is -2 because that's the x to the fourth, so -2. The coefficient in front of the x cubed is -1. Uh-oh, red alert, red alert. There is no x squared, folks. Look, there is no x squared. You still have to put, it's like a place value, folks. I need to put a number there. Well, if there's no x squared there, that means there's a 0, because 0 times x squared is 0. It's not there. So we have to put a 0 in that spot. Don't forget that. You got to look for that, folks. Okay? Then the next coefficient is 4, because that's the x to the first power, and then the constant -5. All right, remember how this works? We're going to bring down the -2. Now we're going to multiply. -1 times -2 is going to be +2. Now I'm going to add. -1 and 2 is 1. Now I'm going to multiply. -1 and 1 is -1. Now I'm going to add. That's -1. I'm going to multiply. -1 times -1 is +1. I'm going to add. I get 5. And I'm going to multiply 1 and 5 and -1 and 5. And I get -5. So I get -10. So, ladies and gentlemen, G of -1 equals -10. Cool. All right. Now, something else that we're going to talk about is what is the end behavior of polynomial functions, where the degree is bigger than 2. So what I'm about to go over with you, again, you can find this in your book. So let me pull in the textbook again, ladies and gentlemen, and let me scroll down, and what I'm going to talk about right now, it's key concept. It's on this page. It's on page 339. Okay, so these are the key concepts that I'm going to go through. All right. Now, I'm going to do my notation a little bit different in my notes, but it's going to mean the same thing. Okay, it's going to mean the same thing. So, again, this notation you see here, I'm going to do it a little bit different. Okay, but it'll mean the same thing. So we're going to see, what does a graph do? How does it end? Okay, based on some things. So here we go, folks. All right, so let's take a look. So let's say the degree is odd. Okay, the degree is odd and the lead coefficient is positive. And again, the degree has to be bigger than 2. So for example, let's say, I'm not going to write out the whole polynomial here. So let's say I have f of x equals, okay, positive lead coefficient, anything positive lead coefficient. So I could say 4, right? I could say 4. And then x to the, okay, the degree has to be odd. Okay, well, it could be a 5. The lead coefficient could be, oh, let's say, it doesn't have to be an integer. I could have a real number positive, so I could say, well, 3/4 x. Okay, to the 7th power. As long as the degree is odd and the lead coefficient is positive, and there could be all kinds of stuff behind that yet, okay? There could be all kinds of stuff behind these, but that's the lead coefficient and the degree. So what does this do? Okay, in general, folks, in general, the graph is going to look like this. Okay, now the middle might be doing all kinds of weird things, but it's the end, again, end behavior that we're interested in. So the middle might not look like that, but the end behavior will be the same. So what is this doing? Okay, so so again, this is x, right? This is x, this is y. Now that's the same as the f of x. F of x represents the y. So what is happening here, folks? So as f of x goes to, now that arrow is going on forever, right? So as the y value, as the f of x, okay, that's going to infinity. As the x value, okay, this is the x value, it's going to the right at all times, is positive infinity. Sorry, I have to make my infinity symbols with 2 circles on its side. I can't do the one motion infinity very well. All right, so positive infinity, both of them. As x, you could reverse that. As x goes to positive infinity, f of x goes to positive infinity. All right, well, what's happening over here? Well, f of x is going to negative infinity. Okay, it's going down forever. And, or as the x value, it's getting smaller and smaller and smaller, goes to negative infinity. All right, so that's what happens. That's the end behavior when the degree is odd and the lead coefficient is positive. The end behavior will always be that way. All right, we got 3 more scenarios to look at. All right, how about an odd degree with a negative coefficient? So for example, f of x equals negative 3x to the, let's say to the 9th power. Okay, again, odd degree, and it has to be bigger than 2. And then again, there could be all kinds of stuff behind that. Well, what is that graph going to look like? Okay, well, that graph is going to kind of look like this. It's going to have this going on. Okay, again, the middle is not going to look like that. We don't care about the middle. We just care about the end behavior. What's happening at the end? Well, in this scenario, folks, the f of x, remember this is f of x, which is the y, that, ladies and gentlemen, is going to positive infinity. But the x, as x is going to, notice the x, this is x going this way, goes to negative infinity. Over here, the f of x, notice it's pointing down, ladies and gentlemen, it's going down. It's going to negative infinity as x goes to, now when we go to the right, when we're going to the right, x is positive infinity. So you see how things changed when we have an odd degree but a negative coefficient. Okay, it flipped from the last one. Okay, let's keep going. We got 2 more scenarios. Trying to make this video as short as I can. All right, this time we have an even degree with a positive lead coefficient. All right, well, even, and again, it has to be bigger than 2, positive. So for example, you might have, whoops, sorry about that, ladies and gentlemen. You might have f of x equals, okay, positive, so let's say, 6 x to the 4th. Any positive lead coefficient with an even degree. And again, there could be all kinds of things behind that. Well, what is that going to look like? Well, that's going to look kind of like a W, but again, the middle, we don't care about the middle, but it's going to do something like this, folks. The middle might be a little bit different depending upon the polynomial, okay? So what's the end behavior? Again, look at what's going on in the end. Well, on the left side, we see that the f of x is going to positive infinity. Now, if you want to put a plus sign in front of that infinity, that's fine. And what's the x value doing? Well, the x value, again, that's going to the left, ladies and gentlemen, is negative infinity. What's happening on the other side? Well, here the f of x is going to positive infinity. And what's the x doing? Well, it's also going to positive infinity. Okay, sorry, I'm going to erase a little bit here. I'm going to erase my little circle right here. It's kind of in the way. All right, so as x goes to positive infinity. Okay, so that's our end behavior in that scenario. Again, look at your book, what I showed you earlier, if that helps you. Okay, so the last scenario here, ladies and gentlemen, is an even degree with a negative lead coefficient. So like f of x equals, let's say, negative 3x to the 6th power. And then there could be all kinds of stuff behind that. Well, think about it, ladies and gentlemen. That last one looked like a W. This one's gonna do this business. Okay, it's gonna kind of like do an M. Again, that middle, we don't care about the middle right now. We just want to know what's the end behavior. So what's happening, folks? Well, the f of x is going to negative infinity. See, the arrow's going down and it's going to the left. So as x goes to negative infinity. Okay, let me get that little dot off of there. There we go, negative infinity. And over here, the f of x is going to negative infinity as x goes to positive infinity. All right, so those are the 4 scenarios. Rewatch any of that if you need to. So that's it, ladies and gentlemen. Excellent. So again, don't forget the stuff that's in your book that you can look at, the examples in your book that you can look at. All right, folks, good luck. I'll be on the next video also. See you soon.